Thank you, Carl, for coming with us. I know it's like Bobby had to wake up very early, and uh, like the rest of the speakers, is good. I will need half an hour just to talk about you, your work, and your skill set, and what you're doing for hemp itself. But I want to tell the audience that this flagship of the many projects that you have been working on, the for this particular Hemp Home Expo, is the possibility of storing energy in a hemp battery. Welcome, Carr. Carr is a scientist, cannabis scientist. He has been in this business over 20 years. He's from Canada as well, like Bobby. Um, well, welcome. The floor is yours, like Kimberly always says.
Thank you, Ramon. Good morning, everyone. Well, good morning, good afternoon, good evening, wherever you are. So great to be here. Yeah, I'm coming out of a bit of a hiatus from the industry. I've been taking a break, and Ramon asked me to come down and speak for a little bit. So that's what I'm doing. So I'm going to try and share my screen here because I've come up with the, and hang on. What was that? We still there?
Yes, we're here.
Yeah, okay. Hang on. I'm trying to get my presentation up here. Okay. Share screen. There it is. All right. Share. How's that? Everybody can see that okay?
It's coming. Yep, it's here. Welcome,
Good,
Carl.
good. All right. So yeah, I've put together a bit of a presentation and to kind of follow on what Ramon is speaking about, and hopefully maybe as well I might touch on a few things. I was listening to JJ and some of the problems that they're having down in Zimbabwe, and did a quick little look-see into a few things. But anyway, yeah, so hemp batteries and whatnot. And so I've kind of changed it a little bit though, because I get a number of questions every year, all the time, in regards to hemp batteries. And so I'm going to try and elucidate a little bit more uh, to try and help people understand in regards to batteries and energy storage. So I've kind of reduced it down to carbon, right? So I'm not going to speak so much about hemp, but basically carbon in general, and plant carbons in particular. Okay, so so that's where I'll start with this, and I'll just go on to the next page. And so, some of these questions that come up, right? So, you know, the competitive advantages of these things, what's the economics of hemp versus alternatives, what is the importance of hemp batteries? And this is where, Ramon was kind of talking. What is a hemp battery? And this is the question I get a lot. Is it better than a lithium battery? Well, this is where I'm going to try and clarify a few things uh, in regards to hemp batteries or energy storage in particular. So next is basically this kind of gives you kind of an overview. Now these are EV batteries, but whether it's an EV battery or a grid storage battery, they're essentially pretty much the same. Okay, so these would be the components of basically your modern battery, right? You get all these different things in here. Now the part, if you can see here, that's probably the most important part of a battery is this thing called graphite, right? So it's a black kind of a hard rock that they mine from the ground. It's in your pencils, it's in all kinds of things. And it is the probably primary ingredient in all batteries, whether it be lithium or alkaline batteries or whatever else. And this is where we're going to be addressing, we're going to look at hemp versus alternatives. First, we have to identify what's the alternative. And when people ask me, is a hemp battery better than a lithium battery? Well, we're not really talking apples to apples or oranges to oranges, right? It's here that we can actually make comparison and look at the alternatives. What are we actually replacing as the alternative? Well, it's graphite, right? The most important part of any battery is graphite or carbon, right? So graphite is an allotrope of carbon, and so is hemp, right? When you carbonize hemp, right, you have an amorphous carbon versus a crystalline carbon like graphite. So this is where we're actually comparing, okay, is when we talk about batteries, okay, and batteries or lithium batteries or these sort of things, what we're really doing, okay, is displacing one particular component, okay, in a battery. And the most important part of that battery, right, it's not lithium, it's graphite. Graphite is mined from the ground, right? It's an important carbon, and this is the one that we're actually looking at, right? So to understand these competitive advantages, right, what are the economics of, I seem to have this, there. Yeah, so we have industrial cannabis versus the alternative, right? So mined graphite. How much graphite is produced worldwide? 1.2, million tons. Tons. Australia isn't a producer yet. Some countries are. Canada, I think, is like sixth, but China is really number one, right? This is where they have the huge, vast supplies, and this is what goes into all batteries, right? So 96% of all anodes in lithium-ion batteries contain graphite, right? Um, they require 10 to 15 times more graphite than lithium. Carbon is essential to battery production, and arguably the most important. The cost wise, it is between $4 and $8 a kilo. Environmental costs. This is where I think is probably one of the most important things. If this whole green climate change thing is actually real, which I doubt that it is. It's just a hoax to raise carbon taxes. Because if it was, I mean, this is going to be a no-brainer when you guys see this, right? So when we look at this, right, what is the global warming potential, right, of graphite? It's almost, 10,000 kilos. Huge number. How does that compare, with hemp, for example? So what are the energy costs? Well, it's 11,000 kilowatt hours, right, is required to produce 1,000 kilos of finished graphite. So there's a lot of energy going into this, right? So here, there's the eco-economics of graphite, right? And where it's all kind of actually going. So it takes a huge, enormous amount of energy, right, to produce batteries in the conventional way that we're doing, using mined minerals and mined resources, right? So can we do this in a more sustainable way, you know? So a life cycle analysis of graphite, right? Production of 1,000 kilos, as I said, right? It takes 11,000 kilowatts of energy, right, to produce that graphite that then goes into a battery. So here's a life cycle analysis of industrial cannabis. So the production of 1 hectare yielded 15 tons. Now that's, depending on the plant that you're using, or the variety that you're using, I should say, and the planting conditions and everything else. So this is just a round kind of a global number, right? It can be upwards or downwards of that number. But the idea behind this is to look at basically, the global warming potential, or the environmental really effects of that it has, right? Now, when we look at these numbers, right, they're completely opposite to what we have for graphite, right? So everything here is in negative numbers, right? Which is important to the environment, right? So you can see all the numbers here, whether it be minus 26 ton or minus 5 tons or whatever, right? They're all negative, meaning that it's actually beneficial to the environment. And that's, I think, probably the most important thing, and help to alleviate some of the problems that are associated with today's society, right? In how much energy that we actually use. I mean, countries like Zimbabwe, for example, yeah, is struggling to come up with solutions or have a stable kind of an energy grid, simply because a lot of that energy is being diverted to other industrial processes. And then, of course, you know, all that energy that's being consumed, is being off gas into the environment, and then other problems then ensue. So this is where hemp, I think, it plays a very important role in the future of battery production. So is in the production of these what's called plant carbons or hard carbons, right? And when you think about it, it makes sense, right? You got something that you have graphite, great product, okay, but is it really sustainable in the long run, right? Because you think, okay, graphite is a finite resource, meaning, there's a limit as to how much there is. Whereas plants, well, we can grow them forever, right? So you got one that you can mine from the ground. The other one, though, you grow from the ground. And of course, which is going to be more sustainable, the one that's grown from the ground. So it's pretty much a no-brainer when you kind of think about these sort of things as to, the alternatives. Well, to me, that it's a no-brainer. It makes it, there is no alternatives. Plant carbons are the future, plain and simple, right? Governments at the moment still don't actually recognize that. Um, they're still very, very slow in uptake. I mean, there was I think I was talking to Australian CRC last year, and I mean, their whole board is basically miners and oil producers, and they're looking at, the battery industry, and yet they're still looking at mining this stuff out of the ground. It's like, okay, you guys are backwards. You're going to end up in the dark ages. So it's like, I don't bother talking to them anymore. So here's some more things in regards to I hopefully, while I'm talking, people are actually reading this, but I should maybe go back and actually read some of this. So what are the plant carbons, right? Environmentally sustainable are among the most prominent issues today. Uh, we have so many of these sustainable problems that we have to deal with, right? And need to develop, proper methods, zero waste concepts, and a circular economy, right? That lends towards the benefit of society, right? And plant carbon is a great example of this way, and to push the economy to neutralize carbon balance, right? Plant carbons can be used and are superior to graphite and possibly graphene. So I don't know if everybody's heard of what graphene is, but I'm going to assume that they do. It's an advanced material that actually comes from graphite. Now, this is where I think we can make more distinction between graphite and plant carbons. So next generation batteries. So, everybody knows about lithium batteries, but probably the beyond lithium, ideas is kind of the sodium ion batteries, right? These are looking to be that next generation of batteries that are going to probably displace lithium. Why? Because they have greater power densities. They're, you know, longer life, all kinds of numerous benefits. The problem, though, with that is that graphite doesn't work well with sodium ion batteries. But guess what? Plant carbons do, right? And not just that, plant carbons also work very, very well with lithium. So these plant carbons can displace all the graphite that we're mining from the ground right now, right? And it's supposed to be an issue. And, it's not limited to one nationality controlling that whole resource. Plants can be grown all over the planet, right? So you have this resource everywhere you go, so you're not limited to graphite just being in China or in Canada or in Australia. In Australia, for example, they have lots of graphite, but guess what? They're not mining any of it. They get everything from China. So it's like, okay, you want to build a battery building industry, but you have no mines for mining it, but you're planning to spend billions of dollars to open up a mine to do this when you can actually be growing it from the ground. Yeah, governments are just retarded. Anyway, so when you compare some of these things, that's what I'm going to do next. Let's compare, plant carbons versus graphite. So a graphite anode has specific capacity of about 350 milliamp hours per gram. Lithium batteries using graphite exhibit a specific energy of more than 160. How does that compare with plant carbons? Well, plant carbons, right, the anode shows a high specific capacity of 420. So that's even better than the graphite, right? And an energy density of about 150. That's today. right? And so they are comparable, right, in the type of thing. So it's like, it almost makes no sense. If you use plant carbons, you get all this negative energy stuff, and it's good for the environment, everything else, cheaper. So it's like, why isn't everybody using plant carbons? Don't know. They're busy raising carbon taxes to pretend that they're actually doing something. Uh, anyway, let's move on. So, life cycle analysis. Now, I left this blank for a number of reasons, right? Because biochar can be produced in a number of different ways, and biochar means different things to different people. So, I'm going to kind of let this fill in itself as we talk. Okay. So, this is hydrochar. This is my preferred method, okay, for actually producing the biochars or plant carbons used for batteries, right? So it's a process basically that takes, basically, as you can see here, any plant material goes into a compressed water environment and heated. Now, of course, the temperature as well, because you're compressing that water, you can use lower temperatures than what it would be expected for pyrolysis as upwards of 1,000 or 2,000 degrees, right? We're actually dealing with numbers that are between 180 and 250, right? And as you can see here in the picture, right, you got water hyacinth, algae, rice husk, corn stover, food waste. I think that's one pretty cool thing too. And we're going to get touch into that in a second. Dairy manure. Um, but basically, what I'm just showing here is basically a process for the production of carbons, what they call hydrochar, right, from plants. And it is these sort of carbons that we can use for a whole litany of things, not just batteries, okay, but for, either solid fuel, soil amendment. I mean, everybody that knows biochar, they know it as a soil amendment, but it can also be used for a whole range of other things. One of them being, like biocoal, or what I talk about here, they have specific energies of about 27, you know, uh, millijoules per kilo, blah, blah, blah. Okay. So it's a very versatile thing that can actually be produced from plants. Now, the problem is, though, with this is there are very, very few, okay, that exist in the world. And the ones that have come online, it's only been very, very recently, right? So there's only one in the United States. Okay, so Somax, and this is at a commercial scale, right? And the same with this other one, Sea Green, came online, I think about 2018 or 2019, and they're in Sweden, right? And I think there's one more basically in Germany. There are very few producers of this kind of energy or this kind of method of production, what's called HTC, or hydrothermal carbonization. Okay. Now, this can be used. One of the beauties of hydrothermal carbonization is for pyrolysis. Normally, okay, the traditional methods that we make charcoal today, which is a biochar, okay, is you take it first, you have to dry it down, then it goes into the system, it's heated up, remove the oxygen from the environment, and then it's basically turned to carbon. Okay. And then, that's either exhausted or it's captured. And that's one of the beauties of hydrochar, is that you don't need to dry it pre pre-production, right? You can take that wet bale right off the field, like, well, it's at 70% moisture, throw it into the system, right? And it'll carbonize it. You're going, how can that be? You're in water. Well, it's because of the specific environment that's there. But what's also beneficial is that you can capture all the residual type of chemicals that are associated with that plant or whatever organic material that you're putting in there, and recover and separate all those different things that are there. And the byproduct that's left over is essentially carbon. And you recover all the other things that come from that water. And that was from back here, for example. As you can see here in HTC, you have this heat, you have the slurry, then you have this liquid solid separation. And that's where you get all your goodies, right? That's taken out, it's dried, and you produce this carbon, right? And then that can be turned into all these other things that actually then go either to batteries or solid fuels or soil amendment, adsorption. You can add it to cement to increase its compressive strength. So you can increase the compressive strength of concrete by 30% by adding a small addition of carbon to that cement. 30%. Now, people are saying, well, it must take a lot of energy, to actually run some of these things. And this is where, again, I can't understand why not every municipality around the world doesn't actually use this system. Because Somax, okay, the one on the bottom here, this is what actually happens, right? They produce 153% net energy is produced through hydrothermal carbonization from waste organic materials. Now, when I say why every municipality, well, think about it. All that poop, that people produce has to go somewhere. It goes to someplace through your toilet, and it's being treated, and then the effluent is being released into the environment. Supposedly clean. But you can actually take all that material, and guess what? You can actually turn it into batteries. you know, After it goes through this process of hydrothermal carbonization, the byproduct, like I say, is carbon. And then you capture all the residual other things that are in there, the toxin. And guess what? If you have something like a coronavirus that's in there, it'll be eliminated. It's destroyed. So we don't have to really worry about treating the water and it getting back into the environment, because guess what? We just turned it into inert carbon that we can then use for any number of other things. And I mean, you're producing energy at the same time, right? So again, it just doesn't make any sense why society and municipalities aren't using this technology, which has, of course, been around for the last 40 or 50 years, right? Why they don't use it, I have no idea. Anyway, moving on. So HTC carbon versus coal. Now, you'll realize in a minute why I'm actually bringing coal into this, because this carbon, like I say, you can convert this plant material, okay, into something that is very similar to coal, right? You can burn it and then release that energy, right? And these are some of the benefits of the hydrochars versus coal, right? Is that you have a lot less ash content and, of course, less sulfur. And these are the things that sometimes when you burn coal in a smokestack, well, guess what? You release that sulfur, acid rain, all kinds of other problems there, right? So this would actually eliminate and help to mediate some of those problems. Of course, you would still release carbon dioxide, because that's going to be the byproduct of heating up the carbon. Then you're going to drive off the carbon dioxide and so on and so forth. Now, one thing I want you to take a look at here that's kind of interesting. Now, I'm a bit all over the place here, okay? I'm not talking necessarily just about batteries, but I'm trying to draw a picture for everyone to understand in regards to the importance of the plant, right? And how it can be used in our society in a more beneficial way than we actually think about it at the present time. So this number here, okay, I will show you on the next page right here. So I have these calorific values, and that's the energy that's in that plant material or in any kind of materials that we actually burn, okay? And so they give it this name of a calorific values. And so, we have different things here, for example. So coal, and I mean, we burn coal all over the world. And that's your energy values right here is 32.6 on average, right? So that's your average anthracite, good quality, high quality coal. Wood is down over here. So, and this would also be very similar to what hemp is. When you're just taking a bale of hemp and you burn it, okay, that's going to be the energy that's released. Now, that's something else that people should think about. Or that's the way I think about plants or trees for that matter, or anything else. What is it? It's like, for me, when I look at a tree, I see a battery. And try and think of it this way. So, because your tree is essentially carbon. How does it grow? It takes carbon dioxide from the atmosphere, holds on to the carbon, and releases the oxygen, CO2, right? And so the plant just goes through a production process and does all this. And then it's basically storing all that carbon, okay? Now, when you cut down that tree, and you dry it, and you put a match to it, what happens to that piece of wood? it catches fire and releases that energy. How does a battery work? Essentially the same way, right? When you think about it, you have, this chemical and other things that are in this thing storing up energy, and then it's released. But the point here that I'm trying to make right now, okay, is you look at these different materials here, vegetable oil, biodiesel, you can see the energy that's embodied within that material per kilo. Okay, natural gas right here at 55. Okay, but go back here, there's actually materials, okay, that when we go through hydrothermal carbonization, we can produce, okay, materials that have a calorific value of upwards of 53, the same as natural gas up here, right? Which is even greater than petrol, right? Or gasoline. So you see, there can be some very important advantages, right, to growing hemp or even other plant materials. Now, this is where I'm going to start talking again about batteries. So because people were thinking, why is he talking about coal? What does that have to do with anything? Well, what is coal? Coal, again, is just another form of carbon, right? That was stored in the ground a very, very long time ago, turned hard, and now we have this rock carbon, right? Now, it was quickly, not so quickly, I should say, understood that, we could actually do something with this. And I talked about this many years ago to others in Australia because I was driving around east of what was it, Melbourne. They got these huge coal pits, and I said, just imagine, right now we take that coal, which is just like a lump of wood, and it has all this energy basically locked in it, and then we dig it out of the ground, then we burn it, release all that energy. Right. Some of it we keep in the form of heat or, to create electricity. And that's what we do with it. But I said, when I was in Australia, there was a couple of things I was looking at big gas and I was looking at this and I said, you know what? We could take coal, you know, and turn it into a battery. And this is exactly what's done. So this was just published actually in January and April of this year, just a couple months ago. So coal-derived carbon anodes. Now, think of this. So instead of, you know, mining coal out of the ground to burn it and release that energy, we can mine it out of the ground and use it to store energy. So we have, say, 1 kilo of this, and we release, it says back here, we'll release 32 megajoules of energy. But guess what? If you turn that into that carbon material that goes into an anode, into a battery, then that battery can, say, work for the next 20, 30 years. How much more energy, okay, can be stored in that battery using coal and then released over and 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 over again? Infinitely, actually. So now we're using that carbon in a very different way than what we were doing before, right? Before we were mining from the ground, putting it to fire to it, releasing all that energy, and then it's gone. But now we can convert that coal, turn it into an anode, okay, that can help to store the energy that we're getting from alternative sources, whether that be water, sun, wind. So imagine that sunny place in Zimbabwe, right? It's getting sun every day and it's storing it in that coal. And then every night it just releases it. But guess what? You still have that coal there. So we'll load it back up again the next day. And then we release it again during the night. Load it back up, release it again. Do that again and again and again for an infinite amount of time. Now that coal is no longer a finite resource, and it's no longer a source of pollution, right? We're actually using it to mitigate some of the problems that we've created in the past by thinking of using carbon in a very different way that we have in the past, right? We think of carbon, we think of it, oh, we burn it and release that energy. But instead, we're using that carbon from plants, whether that be hemp or anything else, right, to store that energy that we're getting from other sources, whether it's sun, wind, water, whatever else. So So that's just one example that I want to show you there. Now, we're going to touch on one more thing here, because back here, I was showing some of the comparisons um, in regards to specific capacity, energy density, and I was talking about some of these numbers. And I said, this is what we're presently doing, right? And now I'm going to show you something. So here's the superior performance of plant carbons, right, or hard carbons. And you can see how it's being synthesized by hydrothermal carbonization. And again, though, like I said, this is not being done on any kind of uh, commercial scale yet. You have just a few places around the world that are actually able to do this on that size, right? I've been doing hydrothermal carbonization for 15 years, right? But it's only mainly been in the lab because can't do it there. But I wanted you to take a look at these numbers here. So look at the high power density now of that material. Look at those numbers and compare those to what I was just talking about before. So again, this is new research coming out. These are the potentials that we actually have for plant carbons. Graphite can't come close to this, not even graphene. So these are numbers that are showing the real potential of what awaits, basically, the things to come. And that's not just that. I wanted to leave off on a couple other things. So, we have other materials that we mine from the ground that we use in batteries, a lot of metals and everything else. And, we'll always, as a society, we'll always be needing metals, I think. It's a very versatile thing. It's what's helped grow our society for the last several thousand years. I mean, without it, we wouldn't have the societies that we have today. But here's an example, though, of a battery that doesn't use really any metal, as its current collector. We have in the picture, there's basically my left hand, I have a piece of graphite. And then on my right hand, okay, I have carbonized hemp stalk. And in the cup is salt water from the ocean. So 70% of the Earth's surface is covered with seawater. I stick those two things into seawater, and then right there, I light up a nice LED lamp. Right, that's a 3 volt. So you can see, actually, just by using two different types of carbon, we can actually produce a battery. And there's going to be so many different ways that we can actually produce batteries, but carbon is essential. And in this one, there's no metals used in this, right? Not in the conventional sense. I mean, you have metal ions in the water that are actually interacting and creating the energy that we have see flowing, but no actual metal sheets that we would traditionally think of. And so, like I say, too, this is a very cheap and simple solution to some of the many problems that we might have. Now, the next one here, Zimbabwe, I was listening to JJ, and he was talking about, some of the problems that he has there. Hopefully I'd like to try and address some of those things here while we're talking, or maybe even later. But how did I come across? I'll talk about this a little bit. So this is a conductive biocrete. So what is this thing right here? Is essentially basically it's a combination of lime, okay, and your charcoal, okay, the carbon. And one day I found it to be there was resistance conductance across the material. I said, so it got me to thinking in regards to it. I said, oh, I wonder if I can make a battery out of this. So I made a simple battery. So this here is just, like I say, lime and carbon. So hempcrete, right? And the reason why I was actually making this actually had to do with hempcrete, right? Trying to find a more, how can we say, a viable way to speed up the production process of creating hempcrete houses. So I said, something that could flow out of a cement mixer, right? And then arrive into your wall, and, we create then a hempcrete. So this is basically just your ground up charcoal and lime to produce that, and it has similar properties to hempcrete, but that's beside the point. Right, what I'm trying to do here is, I said, got me to thinking. I said, I wonder if I can make a battery. So I took the material, took a piece of toilet paper, soaked it basically in salt water, and then this other piece here, the silver tin foil that you have there, is exactly that. It's aluminum foil that you use in your kitchen. So I placed these things on top of one another, and then voila, I was generating 1.03 volts. Now, of course, that's not very much, but it just got me to kind of thinking. And of course, the amperage on that, the milliamps, was negligible. But it got me to thinking. I said, can I store energy in my hempcrete home? That would be kind of novel and unique, interesting. So I said, maybe the walls could be, giant battery. And so that got me to thinking, continued developing, and then came up with this, right? Which is a BIES, Building Integrated Energy Storage. So this red brick here at the top, right, is your, oops, what did I do? Oh. This red brick at the top is basically your conventional hempcrete brick. So anybody that's been paying attention and knows the industry, right, you're usually taking lime and hurd, mixing them together, and then you're making this brick. Well, that's actually, the binder in this one is a magnesium oxide cement that I developed for that. And so this outside part is the hurd. The red is basically just a organic pigment. It's just a regular pigment, a rust pigment, and the same one that you'd use in bricks, right? That's how they get the coloration. Is that iron thing there inside here, right? I had a combination of things. I was trying different materials. This is a prototype, a proof of concept type of idea that I was working on. And in this one here, this is kind of a foamed part that's used, actually the carbon from the husk of the shells of the seed. So because that's another one of those waste products that the hemp industry has been developing. Anyway, I developed this battery. One of the problems that I was kind of thinking, I was going, okay, I can put this in my walls and turn this into a thing. But then I realized that, I can have an 8 foot by 8 foot wall, right? Say, 1 foot thick. And I was going, okay, I'll turn it into a battery. The problem is with that, you'd still only be having 1 volt and, maybe a few amps. So that didn't work. I said, okay, how can I do this? And that's where I came up with this idea here of developing an individual bricks, right? So this one brick was designed as 4.5 volts, which is what is needed for many of your electronics. So this would be, your tablets, your phones, whatever, right? And I had to demonstrate somehow how to utilize these bricks, or what would be functional. So I came up with this, built this brick to be 4.5 volts and about 5 amps, right? And as you can see here, I first kind of was showing this or doing this back on November 23rd, 2017. And it is charging this tablet. Now that I continued thinking about this. So if we count the bricks on this wall, right? Now imagine if each one of those bricks was 5 volts, 5 amps, right? Just keep adding them up. You have 1,000 bricks on the side of your building, and you say, okay, how many volts, how many amps would that be? Well, that's now 5,000 volts, 5,000 amps. How many watts does that turn into? So on and so forth. So, and these can actually then be, these are all just batteries, individual batteries. So you have solar panels on your roof of your house. They charge the external of your wall. That wall then stores that energy, right? That can then be used inside your building. And so, these are some of the ideas that we can actually, foresee as the use of hemp. But hemp's not the be all and end all. I mean, there are a lot of other plants, and I think this is where, speak to JJ in regards to some of these things. I was looking online, but I'm going to finish with this one thing here, and then add something in regards to perhaps JJ, because in regards to corn stover. But I love this saying, cannabis is everything. The ancient Greeks teach us that everything can be everything, and everything can be turned into anything, and anything can be turned into something else. If we can't see the pattern in God's architecture, then we're not looking close enough. Now, Einstein basically came up with a very simple equation that would actually explain some of this here, and that's E equals mc squared, right? E being energy, M being mass or matter, right? The C is the speed of light. But the important parts here is energy and matter, right? What is energy? Energy is disorganized matter. What is matter? Matter is organized energy, right? It's your energy that is then turned into a tree, into a stick into whatever, right? And back and forth. Because then once you burn the tree, you release that energy, so on and so forth. Anyway, I'm going to leave it there. And I'm going to now speak a little bit to JJ, I thought. Um, so I'm going to stop sharing this and kind of go to my screen here. And I wanted to say to JJ basically that, hemp, may or may not be a solution in the future for Zimbabwe. But consider also other plant materials that you have in that country, whether they be rice. Now, I took a look at your country. Your country doesn't produce a whole lot of rice. They import more than they actually produce. Corn is the big thing that your country produces by the looks of it. It was 1.5 million tons. Well, guess what? You can use all that corn stover and actually do the same thing as hempcrete, right? You have corn stover crete. This here that I'm holding in my hand, okay, is sunflower. And this is something that I'm working on soon. Uh, and it's a very interesting product. I don't think there's a whole lot of it in Zimbabwe, but you do have that corn stover. That corn stover can be used, all that waste, right, can actually be used for building material, right? You can do the exact same things that you're doing with the hemp, but you're just using corn stover instead. You can also burn that corn stover. I'm saying burn, go put it through a pyrolysis process to produce those carbons necessary, right, for the batteries, for example, or the carbon necessary to increase the strength of your cements and concretes, or you use that carbon to improve the soil amendments in your soil. Any number of things, and you can use all these plant materials for so many different things. This here, for example, I don't know how well anybody can see that, but this looks a little bit like hempcrete, right? Except that's sunflower, right? This here is probably the most interesting part of the sunflower. That's the pith right inside here. There's a better side there. This white spongy part on the inside. Guess what that is? It just happens to be nature's natural, all natural, and the exact same R value as guess what? Styrofoam. This is natural styrofoam. So, it can be actually broken down and it has the same R value as styrofoam. So, Bobby, all those zip panels that you have going on there that I don't know what's exactly in there as your styrofoam, how about using a natural styrofoam grown right from the ground? We have thousands of acres of this in Canada that we don't use it. So that's an idea right there. And these are some things that I'm actually working on in the future. And of course, the other things in regards to batteries, there's the structure of that styrofoam in there is quite exceptional. This here is an example of rice. Okay, so again, there's all kinds of materials that can actually be used, JJ, to help, with your building plans. That when Zimbabwe's ready and has the amount of acres necessary to grow, and hopefully when they do start growing the hemp, they're going to be growing it for both food and then use the waste, right, to actually build whatever they want with the waste materials. I'm a very strong proponent of always using that acre of land, right, to grow food first. Then you use the waste for all those different things you want to do, right? So anyway, I will leave it there. Thank you very much, everyone. And I guess I'm open to questions.
Thank you, Carl. Once again, your knowledge, your working skills blows everybody minds, and your work have to be. You've got to see the light. Although you already seen the light, because there is a company in Illinois that started rising $1.2 billion to start building a hemp battery plant.
Yeah,
So
well, we'll see what
yeah,
happens with that. I've heard these things many, many times, and I've read some of the things in regards to that plant. So there's some promising things to it. They still haven't been able to produce anything more than some tiny, tiny voltages. So nobody, I think, in the world yet has been able to produce a hemp battery that has the output potential that mine has. Everything I've seen so far has always been very minimal, and all they can do is light up a LED light. I can
Well,
actually charge up a tablet, but
let's
we'll let them catch up.
let's hope that after this expo we can, well, like I always said, the hope is the last thing that we can lost. Lose. There are no many questions except a lot of congratulations, and we're gonna have to move on to Mrs. Sydney, who is waiting for her